So in this video, we're going to take a look at independent and dependent events. So these are two different types of events within probability. So let me give you an example, right? So let's say we've got a bag. Okay, I'll draw a little bag over here, another great drawing as usual. So we've got a bag that has 3 cubes. There's one yellow cube, okay, and actually I'm going to have them be circles instead of cubes because those are, well, easier to draw. So I'll have one yellow circle, we'll have one red circle, and one blue circle. So now, here's what we're going to do. We are going to pick one circle out of this bag here, and then we're going to pick a second circle out of the bag. So, let's say I were to pick my first circle out. Let's pick a yellow one. I grab that, and then I put it back into the bag. So now I still have all 3 in the bag again when I draw my second one. So that would be an example of independent events, because no matter what I draw the first time, so if I draw a yellow, let's call them marbles, I draw a yellow marble out of the bag, and then I put it back, all 3, yellow, red, and blue, are still there. So I could again draw the yellow marble or red or blue. An example of dependent events would be to say I draw a marble out, so again let's say I draw the yellow one out, and then I do not put it back. So now the probability is different because I only have 2 marbles left in the bag. I would only have red and blue. So let's see how this looks. We'll use another tree diagram. So let's go ahead and say, again, I'm going to draw one marble, put it back, and then draw a second marble. So let's look at the probability that I would draw a blue marble first and then a red marble. So we will call this P of blue, comma, red. Oops. Good enough. Okay, so let's take a look. Well, I want to draw a blue one first and then a red one. So let's make a tree diagram to see what all the possible outcomes are. So there's going to be a lot of writing here. Okay, so we could have, let's use a different color. Okay, I could draw the yellow one first. No, I'm just going to write Y, save some time. Oh boy. I could draw the yellow one first, and then yellow again. I could draw yellow and then blue, or I could draw yellow and then red. I could also draw red first, and then yellow. Oops. Red first and then yellow, red first and then blue, or red first and then red. These arrows are just a mess, I apologize. Okay, or I could draw blue first and then yellow, blue first and then blue, or blue first and then red. So you can see we've got 9 possible outcomes, right? I could pick yellow and then yellow, yellow and then blue, yellow and then red, or red and then yellow, red and then blue, red and then red, or blue and then yellow, blue and then blue, or blue and then red. So that's a total of 9 different outcomes I could have if I'm drawing 2 marbles out. And I want to know what's the probability that I pick blue first and red second. Well, only one of those on here is blue and then red. That's this guy here, BR. So that would be 1 out of those 9 possible outcomes, which would mean the probability of blue and then red would be 1/9. Okay, but let's take a look at if we were to do this as dependent events. So this time, I'm not going to put the marble back after I draw it. So let's take a look at what that would do to our probability problem here. So let's say I draw the yellow marble first. Okay, then in this scenario, the yellow marble is no longer there, right? We can imagine it's not there. So the second time that I draw a marble out, I could either get blue or I could get red. Those are my only two options, yellow and then blue or red. Okay, well, let's go ahead and get rid of that X on our yellow guy. Okay, so we could have yellow and then blue, or yellow and then red. Okay, and I do apologize. I know it's taking me a little while to write these things because my screen is being a little slow, but that's okay. You can read it well enough. Okay, the other possibility, I could draw the blue one first. And if I drew the blue one first, again, that blue one would not be going back into the bag, so I could only draw red or yellow. Okay, it's also possible that I could draw the red one first, and with that no longer in the bag, I could draw blue or yellow. Okay, so again, you can see, oh boy, let's rewrite that for you. Again, you can see, this time, instead of 9 possible outcomes, we only have 6. We've got yellow and then blue, yellow and then red, blue and then red, blue and then yellow, red and then blue, or red and then yellow. So, that leaves us with, well, we've got one that's blue and then red, and 6 total. So the probability, when it's a dependent event of drawing blue and then red, is actually 1/6. So hopefully this helps you see kind of the difference between independent and dependent events. Let's do one more practice problem with this, just to make sure we're really getting it. Okay, so we've got Ben, and he's got 3 bananas and 2 apples in a bag. So, and 2 apples. So, let's have a banana. Well, we're just going to use blobs. Banana, 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 and apple, apple. Okay, now, in this problem, we are again going to draw a tree diagram for this, and, well, we can realize, right, if this is going to be an independent or dependent event. So, if he's eating these, it has to be a dependent event, right? Because let's say he draws his first fruit at random, he picks it up, and it's a banana. If he eats it, now there are only 2 bananas left. He can't put that banana back into the bag. So we're going to be looking at the probability of these dependent events. So, let's say he's going to eat a total of 2 fruits while he's waiting for the bus. So let's draw our tree diagram, right? It is possible that the first fruit that he draws will be a banana, and then he could then have the second fruit also be a banana. It could also be the other banana, right? Because he could draw this one first, and then he's got these 2 left. Could be an apple, or it could be an apple. Okay, it's also possible that he would draw he would draw the apple first, and in that case, he could then get another apple, or he could get a banana, and a banana. So there are a total, as you can see, a total of 8 possible outcomes of the 2 fruits that he's going to eat. Okay, and then we want to know, well, we're going to ask a few questions. So the first one is, what is the probability that both fruits that he eats will be bananas? So let's write P of B, comma, B, banana and banana. So again, we've got a total number. Oh boy, what happened there? Okay, we've got a total of 8 bananas, or sorry, a total of 8 possible outcomes, okay? And how many of them are a banana and a banana? Well, we've got 1, 2. So the probability that both fruits that he eats will be bananas is 1/4. Okay, what about another problem. Let's say, what is the probability that neither fruit that he eats will be a banana? So that one would be probability of not B. Okay, so we'll write not B. Oops. Okay, so we'll write not B. Okay, so, well, if he draws a banana first, obviously that's going to be a banana, so we're just going to look at these. Okay, and there's only one time that he would eat an apple and an apple. So that's 1 out of the total 8. So the probability that he does not eat a banana is 1/8. Okay, now we've got another one. So now we're going to do probability that both fruits that he eats will be the same fruit. Okay, so let's look at that. Let's do P same. I do not know why this is not working. There we go. Okay, so probability that they will both be the same. Well, let's take a look. How many of those are there? We've got banana, 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 so that's 2. And we've got apple, apple, so that's 3. So the probability that he will eat the same fruit is 3/8. All right, so there's some practice with independent and dependent events.